Hi Year 12s, I'm just going to show you how you can use your graphical calculator to help you answer transformation of graphs questions. So the other day I showed you the dynamic menu. That's a bit trickier. I will show you that, but it's probably easier just to use the graph menu. So my first question here says that y is 1 over x transforms to y is 1 over x take away 3. Sketch the graph of the image. So I've typed in y equals 1 over x, and I've typed in y equals 1 over x take away 3. I can draw them both. Now just to remind ourselves, so this select button allows me to select both graphs. I'm just going to draw one first. Okay, I'm quite happy with those axes. If I wasn't, I'd press view window or I'd press zoom and adjust them accordingly. Okay, so I'm going to exit and I'm going to select that I want the second graph as well. Okay, so there's 1 over x, and there's 1 over x take away 3. So we can only see a bit of it, so I'm going to press the arrow buttons. There we go, and we can see the other part there. Now, I think there's an asymptote there. There used to be an asymptote at the x-axis. Because it's the y direction, everything's sensible. So the new asymptote should be at y is -3. So I'm just going to check that by drawing it. Yeah, okay, so now in my answer I would just basically copy the ideas from the calculator. So there's my x and y axes. We saw what the original graph looked like, which was the 1 over, and we just move it down. And remember, we want to be a bit careful that we're approaching but not touching the asymptotes, which is the y-axis, and that y is -3, and you would detail y is -3 on there. Okay, so can exit that. If we now have a look at the dynamic menu, okay, it has those equations in there for us. So I'm going to get rid of the -3 at the minute because that doesn't help. So let's say we want to kind of let this one move along to go from 1 over x to 1 over x minus 3. So that's typed in, but I'm going to change, I'm going to change the -3 to be minus a letter. So I'm going to delete that and put alpha a. And then I'm going to say my variable is a. The minute it's -3, but I'm going to set it to go from 0 to 3, okay, in steps of 1. Okay, because we've got minus 1 over x minus a, so it needs to be taking away a positive. Okay, so press dynamic. Right, now my speed is set at stop go, so I have to press execute to see the graph moving. So there we go. We can see it's just slid down. So it's a translation scale factor -3. Add and subtract is translation. Okay, in the y direction. So that seems sensible, doesn't it? So we've sketched it there. Right, if we go back to the graph menu, let's try the second question. Y is 2 to the power x, and it's stretched in the y direction scale factor 1/2. So I'm going to delete this, and I'm going to put in 2 to the power of x. Okay, and now I'm going to do a bit of working out. I'm going to think, okay, so if I stretch, I'm multiplying. If it's in the y direction, I multiply the whole thing by the scale factor. So we get y is 1/2 times 2 to the x. So I can type that in, or I can try tidying it up and see if we get something nice. So this is 2 to the -1 times 2 to the x, which gives us 2 to the x minus 1. Remember, you add the powers. So let's see if that does what I think it should do by typing in the equation I've got. So let's do 2 to the power of x minus 1. Okay, and now we're going to draw the first graph and the second one. We can't see them very well, so I'm going to scroll up a bit. Okay, so the first one was the steeper one, and the second one is the flatter one, as if I've squashed it towards the x-axis. So in the y direction I've stretched it, which makes sense. Okay, scale factor of half. So that has worked. For this particular example, notice it's like replacing x with x minus 1. So it's a little bit like translating in the positive x direction one step. It looks the same, doesn't it? So squashing, which is stretching, is the same as translating in the opposite direction, in the x direction. Okay, so we could again try that on the dynamic graph. Okay, so we'd maybe have 2 to the x minus alpha a, and we set the variable and we'll let it go from 0 to 1 this time, maybe in steps of 0.2, just so it's more exciting. There we go. So if you're not good at spotting the difference between the two graphs, this lets you see one graph moving. It's getting squashed, which is the same as a stretch, scale factor a half. So back up it goes. So let's see. So it's getting stretched, scale factor a half. That seems to make sense. Okay. Back to the graph menu. So the last one is a quadratic. So we'll type it in. So we've got x squared plus 2x plus 1. Right, so the question says this graph is transformed to this other quadratic, and we have to describe the transformation. So we type in the other quadratic as well. So x squared plus 4x plus 4. Okay, so we can see the two graphs side by side. So you can see that the first graph has been translated a little bit to the left. And let's find out where the minimums have gone. So if we do gsolve and then min, and we want it for the first graph, so I'm going to do execute. So the original minimum was at minus 1, 0. Okay, and now if I do exit and oops, and then I want to do gsolve and minimum, and this time we don't want the first graph, so I just use the arrows to choose the other graph and execute. So it's gone to minus 2, 0. So the x coordinate of the minimum has translated one step to the left. So I would write translate minus 1, 0. Okay, so I don't think there's a helpful way of doing that one on the dynamic graph particularly, but you can see from this that if we had written it in completed square form, so we'd have x plus 1 squared minus 1 plus 1 is 0, and this one would be x plus 2 squared minus 4 plus 4 is 0. So it's much easier to see that we've changed x plus 1 to x plus 2, so we've added 1 to the x, so we've done a translation of negative 1 in the x direction.